If your team's trying to move faster with AI or scale more efficiently without reinventing the wheel, InfoQ Dev Summit Munich 2025, this October 15 to 16, might help. It's a practical event. Talks from people in the trenches, sharing what they've actually shipped, fixed, or learned. No big launches or buzzwords, just useful ideas you can take back to your team the next day. Learn more at devsummit.infoq.com. Good day, folks. This is Shane Hastie for the InfoQ Engineering Culture Podcast. I'm sitting down with Thanos Diacakis. Thanos, welcome. Thanks for taking the time to talk to us.
Thanks for having me on. It's a pleasure to be here.
My normal starting point with these conversations is, who's Thanos?
Thanos. Thanos has the gauntlet and it's been getting a lot of recognition since the Marvel movie came out, if anyone knows about that. But more, it's nice to go into Starbucks and go, Thanos like the guy in the movie rather than Thomas. But more seriously, I've been a software engineer for my whole career. I'm nearing about 30 years right now. I have worked at companies sort of big and small, some of my own startups, some bigger companies. I worked at Uber and Included Health, my two most recent bigger employers. And I love software in all forms. I have done anything from firmware all the way down to like assembly code to all the way to now all these fun AI systems and more.
Cool. We got together because you've got some strong opinions. The process of software development sucks. How do we make it better? And you've got some ideas about thinking differently. So let's tackle that first one. Is it a fair statement that the process of software development always sucks?
Not always, but I'm going to take the opinion that it sucks a lot of the time. And to continue a bit of my background, I've been in the industry for about 30 years, coming up to 30 years soon. And one of the things that I've noticed is no matter what team that I go into, the teams struggle with getting software out the door. They may be really good experts, smart people in their field, know their stuff really well, but getting software out the door is always a problem. And one of the things that I observed is maybe there's like 30 or 50 things that one ought to be doing that help you with effective delivery. And again, it depends on what stage you're in and all that stuff. But most of the teams that I work with do like half of those things. And it's not always the same half. So everyone does like their own mix and match of what is good and some things that are completely broken. And my hypothesis is this. People go to college and they learn about algorithms and how to build really complicated things and they get knowledge in certain areas, but no one is taught how to get software into production. They don't learn about the engineering process and all these good things. They go to work their first job and maybe they do Agile with a capital A or Scrum or something like that. And they follow kind of what they see as the process without really knowing why they're doing this. And they might move around a few jobs and maybe collect what they feel were the best practices from different places, but no one knows why they're really doing these things. And that's a problem. That's why people stumble because they're doing stuff without actually knowing. And it's not because they're stupid. No, I know that I used to think that, but I don't anymore. I've been sort of figured out that people were just busy. People have jobs to do. They have things to deliver, and they don't have time to step back and see, oh, okay, let's think about the philosophy of software engineering and see how those things worked. And that's why we end up in this mess. And we end up with software companies that do things in a really broken way that ends up to people not feeling good about their jobs and getting burned out and not being happy about doing what should be a lot of fun, like creating stuff out of nothing. I think software is a lot of fun to make, and we should go back and make it be that way.
So you make the point. These are bright people. They pick up ideas as they go along. And to quote Tom DeMarco, too busy to stop for gas.
That's right. Yeah. And it's hard, right? Because you get under pressure to build a certain kind of thing. And I'm going to call it, usually it's features, right? So you have the business side of things. They want features, features, features. And all they can talk about is about features. So people get conditioned to only think that the only good thing that I do here is features. And we all know, if we sit down and think about it for a minute, that in any software team, there's more than features that you just do. I'm borrowing from the Flow framework. There's four kinds of work. There's features, there is bugs, there's technical debt or investments that you're going to make, and there's risk items. So if the only thing you ever talk to your team about is features, the other things fall on the wayside. And I've seen this happen before. Engineers that should know better, hey, you should take back and sharpen your tools a little bit or fix this thing. That is not going to work in the long run. They just respond to the business and just get conditioned onto this until the architecture and the process and the culture sort of collapses under its own weight because it's not able to deliver any value before you go and do some of the cleanup.
But haven't we been working on this for a long time? I think of team topologies, I think of agile methods, I think of DevOps, I think of name your brand.
There are many good tools out there. And I think, like I said, you go into companies and they've heard of the one, but not necessarily the other. So they heard of DevOps and they set up like an environment that looks kind of a bit DevOpsy and works quite nicely, but they haven't heard of team topology. So now you have to straddle like 8 different teams to get one thing done. You go to some places that are a bit, let's say, more enlightened and they've been in this and they've thought about this and you can see quite nice setups. But my sort of broad observation is that if I go to most places and I say, have you heard about team topologies? I'm going to get like 2 out of 10 that have heard it and are actually implementing it. And from there, there's a lot of nuance to it, right? It's not like you've heard about team topologies and oof, let's go and I can go make a stream-aligned team. There's a bit of understanding of like, okay, what is locality and how does that work? And why do I need to have everyone be in the same place to be able to make decisions quickly? And what is local efficiency versus global efficiency? Like, am I focusing on having a team just, running in their little mouse wheel, or do I care about what I'm shipping out the other end of production? So your point is well taken. Like we do have the right tools and the right methodologies. They're all out there. But the problem is, does the team have the time to step back and see what fits in their current environment? What are the right problems that they're having? What are the right bottlenecks that they need to solve? One of the things that I often find is interesting is teams usually will have one bottleneck, right? If you think like the factory model and you have like a series of machines that make a widget, if the one machine in the middle is the slow one, if you go and fix the one after it, well, that's not going to have any work. And if you fix the one before it, then more work is going to pile on the bottleneck. And once you think about this, it's not really rocket science, right? To realize, and software teams work in the same way. You probably have exactly one bottleneck, and that's the one thing that you need to fix. And when you fix that, the bottleneck will shift somewhere else, and then you need to go find that, repeat it, and go fix the next bottleneck. But typically, what you see is teams figure out what to fix on a much more haphazard way, right? Oh, that is hurting me right now. Let me go fix this. But then if you're, fixing the wrong bottleneck, that doesn't really have an actual effect. So when you ask for some time to go fix this thing, you fixed it, but then there's no change in output. Next time you go ask, hey, can I have some time to fix this other thing? You're probably going to get a no. So I kind of usually advocate of trying to find a bit more of a methodical way to figure out what your bottlenecks are. So then that little risk that you took in investing paid off. You can see the payoff, and then you're more likely to be able to argue to getting a bit more time to do this. And then maybe the idea of investments fits in your company vocabulary, and you can start getting some serious chunks of time where you can build these investments, and improvement over improvement over improvement, you can get to really big improvements at the end of the line.
There's I want to say, leadership stance shift, culture shift that is needed for that.
Yeah, leaders typically go through this set, or at least this is what I've seen. They ask for a feature, and then they get it 4 weeks later and it wasn't what they wanted to. So say, no, 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 this is not what I wanted. So they make this tweak, and then, 2 weeks later, they get something else, not quite what they want. It's delayed. It's a little bit buggy. So when this kind of failure mode happens, the thing that they do next time is they reach for more planning and more predictability. So they say, okay, this time I'm going to write you a really, really tight spec because I know exactly what you want. That's mistake number one. You probably don't know what you want. And I'm going to give it to you in advance. So now when you go build this, I'm going to get exactly what I want. And because you can break it down into really small pieces and figure out how long each of these pieces take, you can tell me exactly how long it's going to take, right? And my argument is to your, what does this leadership look like here, is that's not going to have good results, right? You can't predict what you know in advance. As soon as, the contact with the enemy is made, the plan is going to change and it's going to be out the window. So leadership is really afraid to take the jump and do something different. And they don't know what that different thing is, right? So we know what the different thing is, right? The different thing is we're going to create a team that is a stream-aligned team. If we go a la team topologies, we're going to give them all the tools that they need to get this feature done and get it done in a short period of time. And in the beginning, they're going to fail, but like as they get a little bit better and a little bit better every time, they're going to be able to ship these features in a fairly short period of time. And when the product owners start seeing this, right, we can now deliver on the promises that we made in little small chunks, and we can start building on that and build bigger and bigger and bigger over time. They will be less preoccupied with, can I plan it in advance? Because they get the certainty like, hey, I had this feature idea and I saw it a few days later, not a few weeks later or a few months later. And that trust develops. And now we go away from, I have to make this tighter, to how do we optimize for faster learnings? How do we optimize for that relationship where we can all collaborate and get things out the door, rather than, write a spec, throw it over the wall, someone implements it, throw it over the wall, someone tests it, throw it over the wall. And then when a mistake comes back, and that rework is a complete mess.
When we were chatting earlier, you made the point that this really is thinking differently, and you mentioned 7 mental models. Tell us your 7 mental models.
Yeah, so let's do a quick one through each of them. So the first one we already talked about is that there are 4 categories of work. So engineering doesn't build just features, and we need to think about all these categories, right? And there's maturity level concerns in here, right? If you're a startup, you may be doing 80% feature work and doing 20% investments, and you may not have many risks and not many bugs. But if you're a mature company and you have a product out there, your ratios may look like 30, 30, 30. So you may be doing 30% features, 30% fixing defects, because now you have a lot of customers that are using it, they're reporting things back, and then 30% investments. And people freak out about this, but like your 30% of features when you're doing the other work will produce so much more than doing 100% features and doing no investments anywhere else, because you're going to be so slow in doing those features that it's going to be really bad. My second mental model is that of technical debt and investment, right? And the idea there is that we think of this as a little bank that we can, borrow from the tech debt bank and then pay it back and borrow and pay it back. And my argument here is this is not what usually happens. What usually happens is like sovereign debt. You borrow and you borrow and you borrow and you borrow, and now you're 180% of GDP, and you call the IMF in and they bail you out and it's a disaster. So that's in the software equivalent, that's the sort of the big rewrite. So don't do that. Technical debt comes back to bite you really, really quickly. So if you borrow it, you should be paying it back in the next sprint or the next period. Do not let it simmer for too long, because that really, really slows you down. The third mental model, we also touched upon this, is the one bottleneck. Don't try and do like 100 things at once, but think of where your bottleneck is, fix that. Do some experiments to find out and fix your bottlenecks, but don't try and fix like 10 things at once. That's not going to go well. Mental model number 4 is global versus local efficiency. And I'll explain this a little bit better because I touched upon it earlier. But the idea here is we don't care if everyone is really busy. That doesn't really get you results if you're not shipping product out the door. And the problem with what happens is, like, I think I have this, factory is like I have a machine. It shouldn't be sitting around, should be producing stuff, but then that stuff piles up and you have to store it somewhere and then you lose it, or it gets stolen or it gets rusty. Software is the same way. If you go write stuff that you don't need, it's not going to go to production. Then a PR becomes stale. You forget who wrote it. Who wrote it might have left the company. It has bugs. You can't merge it anymore. So what we want to do is focus on a few things and get these few things shipped before we start new things. And it doesn't matter if some team member isn't doing something at all times, because maybe when a bug comes in, they can go work on that. If they start a new project, now they may have questions and they might go distract someone that is working on something more important. And that usually causes priority inversion. So focus on what it takes to get software out the door, work backwards from there on your bottlenecks, and make sure you're globally efficient. Like you're getting value to your customer rather than like, hey, Bob was busy all 8 hours of yesterday. That doesn't really do anything for you. You're paying Bob the same amount, whether he's bugging people that are actually shipping something out the door or not. So that was number 4. Number 5 is think of work in process as something that's really, really evil. It's like a hidden thing that you don't really see, but it just sucks resources. It's kind of related to global versus local efficiency. It's starting things that are not going to see the light of day. We see this. You plan a sprint and then you say, and let's put some reach goals in here just in case we get to them. And then someone is blocked on one of the important things. They go start a reach goal and the other thing becomes unblocked and the reach goal just falls out the next sprint because something important came through. And that work is just thrown away work. And maybe it's just the PR is sitting and confusing people, or maybe they merged a little bit of it and then it broke things. So my advice here is visualize work in process so you can see what you're doing at all times and limit it. That will help you focusing on shipping things rather than starting things, which is not super helpful. Mental model number 6 is planning v doing. And my argument here is get really good at doing before you start getting really good at planning. The joke that I make is someone wants to tell you how long it's going to take to go from the East Coast of the US to the West Coast to the level of fidelity of minutes. And they have a horse and buggy that breaks down halfway through town. It's like, you should maybe develop a car first. Maybe get the horse and buggy to work, maybe then get to a car, get from city to city before you can plan how long it's going to take to get across the country. And I won't speak too much because we talked about this with a leadership issue there, but like get really good at doing. You're not going to get good at planning before you can get good at doing. And the last one that I have here for you is quality versus speed. And this is a fun one because I think a lot of people associate if you go fast, you can have poor quality. And that could certainly be the case if you're in YOLO mode, which is like, I'm just going to build stuff and just put it out the door. But think of quality as your ability to also fix your previous mistakes. So if you have a process that takes 2 weeks to develop something and then a week to QA it, that means a mistake will take at least a week, maybe more than that, to make it into production. So that is not quality in my mind, right? Because by the time you've shipped that bug fix, you're going to have found 3 more, and that release is probably going to make 3 more bug fixes and so on and so forth, right? So speed and quality need to work together. So you need to put in the systems in place that enable you to have speed and quality at the same time. And one aspect of quality is also going to come from speed. So don't think of these as competing, but think of how you can make those to sort of synergize together. And those were kind of my 7. They're a little bit all over the software development process, but hopefully they give listeners some interesting ideas of how to think about their problems in ways they might have not gone through before.
So how do we put this together into I want to improve my software development process? Maybe I'm a newly promoted team lead. I'm seeing some of the challenges as an individual contributor. I've felt the challenges. Now I've got some authority. I've got in a position where I can start doing something. How do I synthesize this into a way of working?
Funny you should ask that, because I think that's what everyone asks me of, how do I do this? And the problem that I see is people just get lost. Like, holy mackerel, you just gave me like 7 mental models. Okay, that's great. But now what do? I go to work on Monday, and how do I fix this? So I've tried to synthesize this in a 4-step way that kind of walks you through it. And this is not the only way to do it, but it's a way to get your head around it in a way that is relatively straightforward, and you can kind of walk through it linearly. It's not always linear. When I work through clients with this, sometimes you start with 1, you go to 2, you jump back to 1, you go back to 3. So you have a little bit of room to maneuver here in the 4 steps that I'll give you. But if you're going 4, 3, 2, 1 all the time, you're probably doing something wrong. So my 4 steps are iterations, quality, complexity, and planning. So let me walk you through one at a time. So my first step is iteration. And the goal here is you need to be able to get stuff to your production quickly, in days, ideally by the end of this process, in multiple times a day, before you can do anything else. You're not going to be able to work on anything much if it takes you days or weeks to get stuff into production. So this means that from linters to CI/CD pipelines to ways to get consensus to what goes out in production, to notifying your customers of what's out there, all the stuff in that pipeline is a good phase of iteration. So the first thing that we typically start from is, how is our iteration? How does that work? What do we need to do to improve our ability to get code into production? Now, very close to that comes number 2, which is quality. If you just ship to production with no concern for quality, that's YOLO mode, not good. So we want to build the systems that go through that. What is our testing, ideally automated testing, that go in here? Are we monitoring production, observability? Do we know what is happening in production? Like, is what's in production what we think is in production, right? A lot of people think they know how production works, but then they go look in the metrics and logs and things of that nature and go, oh, wait a second, how does that even work? And those go hand in hand. You might do a little iteration, a little quality, and go back and forth until you're at an acceptable pace. But now you're at a relatively good point where you can have an idea and take it to production with reasonable quality in some fairly short period of time. Again, days, not weeks or months. And as you're going through these, by the way, you're thinking of culture, process, and technology, and what you can do to improve, finding your bottlenecks for each one of these things, and working on systems to improve. Now, the thing that usually happens with teams once they have iterations and quality down is that they start building up complexity. In complexity, don't think of this as only your architecture and what happens there, but this could be procedural complexity. This could be the cognitive load of understanding how the whole system works. This could be end user features and how those interact with each other. And hey, we just built this new ordering thing over here, but it's affecting this other thing over there. And every feature interacts with every other feature. And it's a little bit of a mess to figure out. Or maybe vendor complexity. It could be appealing to different customer bases. So there's many axes upon which complexity scales. And together with work in process, that complexity is one of my most hated enemies in this thing, because we think we're so smart as humans, but we're really like small lizard brains in some ways. And it's really hard to get our heads around complexity. So I like to go in and start looking at the complexity in this 3rd phase and saying, okay, what can we do to keep this down? How can we put good interfaces between things so things scale linearly, not exponentially? So as I add features, can I build the architecture so I can test them separately? And I don't have to test the combination of everything with everything else, because we eventually cannot do that. Culture complexity is another fun one. As you scale up the teams and everyone is doing things in different ways, a common thing that comes up is, do we want to have like standardized across systems or languages or platforms or frameworks or whatnot? And these are oftentimes complex challenges, right? The benefits of standardization is that, you may have one team that's supporting it and you have built expertise in there, but then you kind of stifle innovation, because what if this is a really new cool tool that you can use to make your life a lot easier over here? And these don't always have easy answers, but there's some methodology and tools that we have to go into play and answer those. But, thinking thoughtfully through these will usually end up with good results rather than just winging it. And now when you've got complexity tamed, again, none of these, by the way, is like, when I say when you have complexity tamed, it's never going to be done. But as you get to a point where that's acceptable and you keep iterating on this loop, I think that's where we go to planning and predictability. Once we have strung enough of these things together, we now have a team that is cohesive, or multiple teams if it's a larger organization. And there's a rhythm to it now, right? We know how this works. We're getting pretty good at it. Now I think we can get to the point where we can string this thing together and saying, yeah, we're pretty good on like planning a quarter out. Now we're good at looking at what are the themes of the work that we're doing. We have a pretty good idea of our systems. We know our ratios of how much feature work versus investments versus bugs we're doing. And we can look at those and have some reasonable ideas for planning that are not just junk in, junk out, right? What really annoys me is you go to like the quarterly or yearly planning meeting and you do like 2 weeks worth of work. And then it starts in 2 weeks into it, like the whole thing is out the window because something else is different. And then you do again the same thing next year. And it's like, what's the point? So I want my planning and predictability exercises to be something where we came close to the plan and then we can repeat it because there's not much point in making plans if we can't really get to follow at least some part of them. You know, the adage of planning, it's worth its weight in gold, but plans are worthless. So, the exercise of thinking through things is really good, but be prepared. Plans change. It's okay to move things around, but find that you're getting some benefit for these activities rather than just doing them to feel better.
4 practical steps. How long does it take?
Oh, that hugely varies. If you're a startup and you have like 3 engineers and it's a greenfield project, you could have a lot of these things figured out in a quarter. But there's a lot of ongoing processes that you have here that you're going to carry for life. Like these are not things that are sort of one and done. If you have a more realistic example, I'll give you an example. This one current client that I have. There's like 3 or 4 engineers altogether in the team. And we've been doing about 20% of effort in investments in these sort of things. And we started about a year and change ago. And it was some existing code base. And what we did is investing 20%, cycle after cycle, we were getting like 1, 2, 3, 4% improvements week on week, right? When you add these up after like a year, they are now crushing it. They're eating the competition's lunch. They have a lean, mean engineering machine. They can build fairly complex features in no time. Architecture is under control, iterations, quality, speed, all these are going really great. But to do this, they didn't really sacrifice any velocity as they were going through. So for this year and a half or so that we were doing this, they were putting features out without really stopping and really like chewing into the market. So you can kind of parallelize these things. Again, it's a delicate balance of how you do this. We could have maybe done this in 6 months if we just stopped everything and just did investments, but we didn't want to do that because the market is not going to stop and wait for you. So you got to find the right way to do this, and it can go from slow to fast. This is not an overnight thing, right? There is effort involved here. You're looking to spending at least 20 or 30% in looking to how you work in addition to actually doing the work that you do. So it's not a trivial amount, but if you ask me, there is no other way. If you spend all your time and just build new shiny stuff and pay no attention to the machine that is actually doing this work, you collapse under your own weight sooner than you think. You can able to hide it for a while, and that's where companies get like the not fun part of working, where things sort of get ugly in the inside and take all the fun out of it, but it does come back and bite you pretty fast.
Culture, process, technology. The technology you mentioned, for instance, get your DevOps pipeline sorted, and we know how to do that. The processes, I think you've given us a pretty sensible way of thinking about the software engineering process. How do we get culture, and I want to say right in inverted commas?
Thoughtfully, consistently. That's a challenging problem, right? Because, the joke culture eats strategy for breakfast and it eats everything else for breakfast as well. What is culture, right? Culture is how we do things in a given org. And people learn culture not because they're told what it is, they're told process, they're not told culture. They gate culture by sort of looking at what everyone else is doing. So process is an interesting lever you have. You can pull process in really fast. Like everyone should do this. And you can reward on everyone doing this or not. And eventually, if everyone does start doing this, that can become the culture. I think the thing that I've found is why I kind of insist that my clients work on all three of these is that if you have the right culture and the right process, but your technology is way off, you're still going to fail. And you're maybe blaming it on something else that was happening. Maybe blame it on culture. So for example, let's say you were doing manual testing, which we all know doesn't really work that well, and you probably should automate. And if you're doing manual testing and that fails, we might, blame it on culture and saying we weren't testing hard enough. We weren't like, so into it, right? So culture gets the blame, whereas that was a tech problem. That was not the right approach to things. So I think you have to think about this holistically. And when it comes to culture, like I prime it with process because that's kind of the tool that you have. But then you also need to lead with communications and good examples. So communications is you keep repeating the same thing, like what you want it to be over and over again, and you have to show the values, right? You can't just say it, but you have to do it. So you cannot, for example, say that we have a culture where engineers can do the right thing for engineering, but then not give them any time to work on technical debt and investments. because that's not setting the right culture. You cannot say, hey, yeah, that's nice. I'll give you a week for a fix-it sprint. And that's the only time that you get, because that's just saying, one thing and then implementing a different thing. So I think as a leader, you have to put your money where your mouth is and help the development team do the right sort of things. It's actually a little bit mind-blowing if you think about it. We do sometimes things in software that in any other industry would be the most insane thing ever. Like you wouldn't have a surgeon say, I'm kind of in a hurry, so I'm going to skip washing my hands because I got to get the surgery done. Or like, hey, we just finished this bridge. We're going to do the load calculations at the end because, that's just paperwork. And we don't need the barriers on the side. Let's get a little bit of traffic on it to see how the bridge is working. And we'll put the barriers on the side afterwards. And you see where I'm going, right? Like we do this in software all the time, and that's just not cool. There's some things, there are some good practices that are good that we should be doing because there's good reasons for them. And just skimping on those leads to bad things. Now, on a positive note, like we do have the right tools in place. Like this can be good, this can be fun. And it's just a matter of like combining all the right bits and pieces in one place and staying agile with a small a and staying adaptive to things to get a team in a good location.
How quickly can we adapt and learn?
That varies, right? There's a lot of pressures on teams. So if you have like a fairly small team that is just in the beginning of their journey, they are super eager to go and, build product market fit and get things out the door because they're not going to be around. And that is maybe the time that you'll give them a bit more leeway and saying, okay, maybe this is the time you can create a little bit more technical debt because you're not going to be around to do that. At the same time, you have to stay adaptable and learn. You cannot pretend that these choices that you're making don't exist, right? You have to keep a very close eye on them and create these really fast learning cycles of what does the market need? How does this technology work? How does this product that I'm building for the first time work? When you get to bigger companies and bigger teams, the existing processes that have been sort of, and maybe culture sometimes have been sort of ossified in there, makes it a bit harder to adapt and learn. I don't know if you heard that story with the gorillas in the cage, but it's sort of fascinating. I'm trying to find out if this is actually true or not, but it's still pretty instructive. But there's 8 gorillas in a cage. There's a ladder with some bananas on the top, and one gorilla climbs to the top to try to get the bananas, and they spray the whole cage of the gorillas with cold water. It's a bit cruel of an experiment. So then another gorilla tries to do the same thing, and they get sprayed with cold water. So they basically stop. Right? They don't go up there. So now they take a gorilla out of the cage, they send them upstate, and they grab a new fresh gorilla that has never been in the cage. The new gorilla sees the bananas, climbs up the cage. The other gorillas will grab them and beat them so they don't all get wet. And the story goes that they keep rotating all the gorillas until none of the gorillas have ever gotten wet. Yet when a new gorilla goes in, all the gorillas beat them up without knowing why. And that is conceivably how culture works, right? You keep doing the same thing and don't know why you're doing the same thing. And it takes a bit of effort to figure out, okay, what's happening here? Why are we doing this? Does this still make sense? Is this protecting something, right? Oftentimes you'll put a constraint around a bottleneck. So we had this bottleneck, maybe Bob is the only guy that knows something about our system. And so we protect Bob's time. And then when we solve this bottleneck, now we need to go remove this protection because we don't need it anymore because the bottleneck has shifted somewhere else and this bottleneck is not doing something. So there's a lot of these artifacts that were there to protect something in culture, process, or technology that eventually need to go away to keep forward motion going there.
Thanos, a lot of ideas in there. I find myself in vehement agreement. But if people want to continue the conversation, where can they find you?
They can find me on LinkedIn. I post there daily with topics around these issues.
Well, thank you so much for taking the time to talk to us today.
This was a fun conversation. I'm glad you had me on, Shane.